The Canary current upwelling system is one of the Earth's 4 major eastern boundary upwelling systems, where the cold nutrient-rich water upwells along the coast and exports the phytoplankton fixed carbon into the North Atlantic Ocean through the Ekman transport. The Canary current upwelling system (CCUS) supports a highly productive ecosystem and sustains fisheries of significant commercial value. Due to its broad latitudinal range, it is typically divided into distinct upwelling zones with varying features. Mesoscale processes such as eddies and filaments are known to influence the productivity of these upwelling areas. The figures shows that the Canary current flows southward between Cape Medusa and Cape Blanc along the African coast. Next to the Cape Blanc, it can be seen the Canary current detach from the coast and flow offshore.
Now, let's look at the physical oceanography process behind upwelling. The Canary Current Upwelling System (CCUS) is one of the main eastern boundary upwelling systems in the world. This phenomenon happens because of wind patterns and how they affect the ocean waters. When the northeast trade wind blows along the northwest coast of Africa, the Coriolis effect that is caused by the Earth's rotation pushes the surface water away from the shore. This causes cold and nutrient-rich water from the deep ocean to move up and take its place. The strength and location of this upwelling, however, changes with the seasons. It is the strongest in the spring and summer, when the winds are strongest because of Azores high pressure system. Furthermore, the shape of the coastline and the seafloor known as bathymetry also affects how and where the upwelling happens. In addition to the wind, ocean waves that stay close to the coastal trapped waves and small spinning currents known as eddy also play a role. They can be responsible in changing the strength of the upwelling and help spread nutrient further out into the ocean.
First, let's look at how upwelling affect weather. When cold water rises to the surface, it cools the air above it. This creates a stable air layer which limits vertical air movement. Because of that, we mostly get low clouds like fog and stratocumulus instead of tall rain clouds. As a result, rainfall is reduced. That's why the areas along the northwest coast of Africa like Western Sahara and Southern Morocco are dry even though they are near to the ocean. Finally, the temperature difference between land and the ocean causes morning fog and mist, especially in coastal cities like Agadir in Morocco or Nouadhibou in Mauritania. Looking at the ocean, upwelling has several major effects. First, it brings colder water to the surface, which lowers the surface temperature by 4 to 8 degrees. More importantly, this deep water is rich in nutrients like nitrate, phosphate, and iron. These nutrients cause phytoplankton blooms, basically ocean algae which form the base of the marine food web. This leads to high biodiversity and support massive fish population, including sardines and anchovies, especially off the coast of Morocco, Mauritania, and Senegal. However, in some cases, too much biological activity and decay can reduce oxygen level near the coast, causing low oxygen zones that are stressful for marine life. Finally, let's look at the climate effect. Upwelling plays a role in cooling the coast. By bringing cold water to the surface, it helps moderate temperatures along the North Atlantic coast of Africa. That's why coastal cities are often cooler than inland desert areas. It also strengthens high pressure systems like the Azores High, which affect regional wind and rainfall patterns. Another interesting impact is that it helps transport Saharan dust across the Atlantic Ocean. The trade winds carry this dust all the way to the Amazon, where it helps fertilize rainforests. And lastly, upwelling supports the ocean's carbon sink role. Phytoplankton absorb carbon dioxide from the air, and when they die, some sink to the deep ocean, locking away carbon and helping slow down climate change.
When we talk about the ocean's impact on human life, it's much more than just a source of seafood. For millions, especially in West Africa, fisheries are important for jobs, income, and daily meals. But beyond food, the ocean plays a major role in regulating climate. In places like North Africa and the Iberian Peninsula, it helps cool the coast and makes farming more sustainable. It also supports our diet by providing affordable protein and essential omega-3s that benefit our brains and heart. On top of that, healthy ocean system protect us a cooler and oxygen-rich waters to reduce harmful algal bloom that can produce toxins. So, a thriving ocean doesn't just support marine life, it directly supports ours
The
too.
Canary current upwelling system is important to Northwest Africa's economy. It produces over 3.5 million tons of fish each year. Most are small pelagic species like sardines and anchovies. These fish support many local fisheries. The system also brings strong export earnings. Much of the catch is sent to Europe and Asia. This trade provides valuable foreign income. Fish abundance has helped grow processing and canning industries. These industries create jobs and add value. Regional trade remains low. Less than 1% of the fish is traded between African countries. Removing trade barriers could boost the economy.
These are the effects of climate change on the system. According to MILS, climate change causes ocean to heat up. This rising SST can negatively impact coastal ecosystem. SST changes can lead to higher acidification and changes in thermocline, which is important for upwelling. Next, upwelling is facilitated by wind that transports surface water offshore and replaces it with cold water from below. Changes in wind speed and direction can disrupt the formation of the system. And finally, nutrients. Plankton community require nutrients to survive. Climate change causes the decrease of nutrient supply from below, which can affect phytoplankton biomass. Phytoplankton is crucial as the foundation of marine food webs and ocean productivity.